Kevin Knuth, an associate professor of physics at the University at Albany with over 2 decades of experience in machine learning algorithms for astrophysics, Bayesian probability theory, information theory, robotics, signal processing, neuroscience, nonlinear dynamics, quantum mechanics, and many other areas. He's also the editor of the peer-review open access journal Entropy, as well as being a member of the Scientific Coalition for UAP Studies. In September 2019, he published Estimating Flight Characteristics of Anomalous Unidentified Aerial Vehicles, co-authored by Robert Powell and Peter Reale. In that paper, he described UAPs as reportedly being structured craft that exhibit impossible flight characteristics. He joins us today to discuss the physics and flight characteristics of UAP and explore the 5 observables, which are positive lift, sudden acceleration, hypersonic velocity without signatures, transmedium travel, and low observability.
Great. So I'm going to talk about flight characteristics and physics of UAPs, hoping to make some headway into the understanding of their physics. And I've been working with the UAP-X group, founded by Senior Chief Kevin Day, who you see front and center. And we're basically a group of former Navy people and scientists and engineers who are actively working to collect data on UAPs. So we've actually had some sense in recording data, recording images of UAPs. So I'll mention that a little bit. And of course, we learned from Elizondo in the from the AATIP program that they developed or introduced the 5, what they call the 5 observables. The first one is positive lift. The second is sudden or instantaneous acceleration. As a physicist, I get a little nervous when I hear the word instantaneous anything because that's not measurable, but I'll mention that a little later. Very high rates of acceleration is what they're noting, and at times immeasurably high. 3, hypersonic velocity without signature. 4, transmedium travel. And 5, low observability or cloaking. So I'll talk about each of these a bit and more. So of course, I gave this talk recently. I used these slides for the presentation that we made to a special session of on UAPs at the American Institute for Aeronautics and Astronautics. And we were very pleased to be invited to give talks at this meeting. It's basically the world premier conference in aeronautics and astronautics. And so to be able to address aeronautical engineers and discuss this with them was very exciting. And of course, we were careful. So this slide is to reinforce the idea that, of course, most UAPs are misidentifications of astronomic and atmospheric phenomena or conventional aircraft, and another large proportion are hoaxes. And it really comes down to about only 3% of UAP are of interest. And what I'm really interested in is the subset of those that appear to be anomalous unidentified aircraft. So here's an example of mistaken identity. This is a purported photo of a UAP, and I'm a bird watcher. I've been a bird watcher since I was 5 years old. My father was a wildlife artist, so I looked at this and was able to identify it pretty quickly. It's a seagull. Very often when people take photos of scenery and, oh, there's a strange object in the picture that I didn't see while I was there, well, it usually is an insect or a bird. Images are sometimes also altered. So here's an image where clearly the stars aren't real, and you can probably guess what else also is not real. Although I've been told that this was meant to be a mock-up image just illustrating what the lights over Phoenix looked like. So in all fairness, this might not have been put out as a purported UAP. but instead an illustration. But it makes the point. And the important point in my mind is that some UAP have been partially identified as structured craft. The whole idea of it's funny. There's people, will use anything to argue in these situations, and the fact that these things are called unidentified, whatever, leads some to say, well, if it's unidentified, it could be anything, and that's really not true. That's not how identification works. And I like to give, as a bird watcher, I like to give bird watching examples. I have a lot of, in my notes, when I go on trips, I have lots of birds that remain unidentified. I did identify them as a bird, so that's what I mean by partial identification. And very often I can see a bird in the distance and say, oh, that's a heron, or that's a pigeon. I might not know what kind of heron it is, depending on where I am, but I can partially identify it as a heron, or identify something as a hawk and not an eagle. But I don't know if it's a red-tailed hawk or a red-shouldered hawk. So identification isn't a binary thing, and it also depends on what level of description you're interested in. Somebody might just be excited to see a bird, and that's it. Oh, I saw a bird, and they're done. It's been, in their mind, it's been identified and case closed. And what I'm interested in is when people are able to say, oh, clearly it was a structured craft. I have no idea what kind of craft it was, but it was a craft, and that's important, and that happens. These are the cases that interest me. So I'm going to go through some of these characteristics and add on a few others. All right, and I've got my Zoom window covering up part of my screen, so I can't see it. All right, so this is an example of positive lift. This is the video, the Homeland Security video from Puerto Rico in 2013. And this makes the case, is a good example. You see there's no apparent lift or control surfaces. It's unknown how lift is generated. These objects are known to be capable of flying or hovering for long periods of time. And we know from various case reports that when these things are chased by jets, the jets often run low on fuel and have to return. So I have two examples here: Washington, D.C. in 1952, and Lakenheath, England in 1956 are two cases where that's occurred. And Elizondo has said in his presentations that these things have been observed to hover for minutes, hours, days. And so you get large craft hovering for days. It is pretty hard to imagine how you would do this and not run low on fuel. So the mechanisms for generating lift are really unknown at this point. And the other thing that we see is, or don't see, is we see no heat signature or from the engines, and we don't see any exhaust. So this again is an infrared image, and you don't see any hot exhaust coming out of there, and it's not quite clear that it's no obvious heat from the engines. And I'll point that out in a few other videos. Another point, another one of the 5 observables is the sudden or instantaneous acceleration. When they use the word instantaneous, they mean it's too high to measure. So we've looked at several cases and published a peer-reviewed paper on a few of these cases demonstrating these accelerations. So one of these, probably the best example of a high acceleration, is the case from Kevin Day, who you saw a picture of earlier, on the USS Princeton, monitoring when they first discovered these tic-tac shaped objects in the Nimitz encounter in 2004. He observed them basically cruising along at an altitude of 28,000 feet, moving at about 100 knots horizontal velocity. And they would then sometimes drop down to the sea surface or 50 feet above the sea in 0.78 seconds was the measured drop time. So you're basically accelerating. You start accelerating in the y direction downward, and you then, of course, are going to come to rest just above the sea surface. So you're going to have to decelerate again. And you can estimate, you can put bounds on the minimum acceleration to do this. The minimum acceleration to do this would be to accelerate at a rate A to the midpoint and then decelerate at the same rate to your stopping point. That would give you the minimum acceleration. That's what we're going to estimate here. And putting some uncertainties on the measured heights, these things varied in height by about 300 feet, about 10%. And so, and of course, we have some uncertainties in the time as well. We introduce that for good measure. And when you plot a histogram of Monte Carlo samples based on all these uncertainties, you find that the most probable acceleration is over 5,000 Gs. So you're looking at least 5,000 times the acceleration of gravity to accelerate to the midpoint and then decelerate to the stopping point. Now, of course, you could have a different acceleration profile, but that would be a greater acceleration. You could accelerate much faster to a constant and then travel at a constant speed and then decelerate at a much higher rate to stop. That would be possible too, but that would be a higher acceleration. So this is the minimum possible acceleration, which is impressive. And I should make some statements about this. I should have added these to my slides. Forgive me, I'm going to pop over and open up another talk and show some slides from this. I want to show what 5,000 Gs of acceleration gives you. These are the equations that you would use to calculate how far you would travel after a certain amount of time in the spacecraft while you're accelerating at a certain acceleration A. And these are the equations we would use if this thing were going to be accelerating for any period of time, because you're going to very quickly reach relativistic speeds. How quickly? Well, that's a good question. Let me go to the velocity here. Here we go, velocities. So just to give you some idea, at 1 G acceleration, this is a graph of your velocity over time. And you can see that at 1 G of acceleration basically gets you to 90% the speed of light after a little over 2 years. So it would take you about, if you accelerate at 1 G and can keep that up, you'll be traveling about 90% the speed of light in about 2 years. Now, we're talking like 5,000 Gs, so this is 1,000 Gs of acceleration. You can get up to 80% the speed of light in 11 hours. So we don't know if these tic-tac objects can travel in space and if they can accelerate in space. There is some indication that they were detected by radar operators on the USS Princeton, the radar operators who are watching for ICBMs. That Kevin Day has told me personally that they were observed to drop in out of orbit to 80,000 feet when they showed up on his radar. But nobody's come forward to corroborate that yet. So assuming that these tic-tac shaped objects could accelerate in space, even if they accelerate at 1/5 the rate, 1,000 Gs, you can see that they're in a half a day, they're already traveling at 80% the speed of light. It only takes an hour of this acceleration to get up to 1/10 the speed of light and 3 hours to reach 30% the speed of light. So this is a really impressive rate of acceleration. And I like to say this, why people often ask, skeptics often ask, why do people always assume that these things are spacecraft? And the answer is quite simple, because they accelerate and travel at speeds that are spacecraft-like speeds. Of course, most typical eyewitnesses wouldn't be able to recognize that, but they can recognize unreasonably fast. And these things are unreasonably fast. At these accelerations, how far can you travel? That's an important question. So here, let me see. I'll put up even at 100 Gs. So I only have graphs here for 100 Gs. These were some of our early estimates before we worked this out in detail with this data here. So don't go by these numbers, but basically at 100 Gs, this is the distance as a function of time. So, so in 3 months of ship time at 100 G acceleration, you're already traveled a long ways. To get to the other side of the galaxy will take you a little more than 3.5 months. Now that's ship time, of course. The time in the rest of the galaxy, they're going to see this take. Basically, you're traveling something like 60 to 80,000 light years. So, so what do I have here? I guess this is around 100 light years. So they're going to see this take 100,000 years. But for the people in the ship, in the Tic Tac, accelerating at 100 G. So this graph is actually for accelerating halfway and decelerating the other half. They're going to be able to traverse the galaxy in just over 3.5 months, which is really impressive. So these things do act like spacecraft. In fact, I would say that they don't just have the same speed and accelerations that you would expect from spacecraft. They have the speed and accelerations of exceptional spacecraft. That's something that you would only dream of, right? So these spacecraft are probably better than what we have in our science fiction. And that's an important point to note. All right, let me go back to this presentation here. All right, so yeah, so we've measured accelerations ranging from about 70 Gs all the way up to 5,000 Gs. All right. We see that these things have achieve hypersonic velocities with no signatures. The hypersonic speeds, this Tic Tac dropping from 28,000 feet to sea level in 0.78 seconds under 5,000 G acceleration, the speed at the midpoint would have to be on the order of 46,000 miles an hour, or Mach 60. That's about the same speed as the New Horizons probe that has now passed Pluto. So this thing's traveling as fast as one of our fastest spacecraft, and accelerated to that speed in less than 0.3 of a second, or on the order of 0.3 of a second, which is really insane. Now these speeds aren't unusual. In fact, Hermann Oberth, the rocketry pioneer, mentor of von Braun, gave a presentation in 1954 on UFOs, and he noted that their speeds had been tracked on radar up to Mach 55, which is about 42,000 miles an hour. So the numbers we're estimating here are consistent with other observations that were made in 1950s, which again begs the question, why was no one concerned about this? Why was no one neither concerned nor interested? It's fascinating and a little scary. Now, the other problem is energy deposition. That's a crazy amount of kinetic energy, and it just doesn't disappear when the object stops. That drop maneuver should have deposited on the order of, if we don't know the mass of the Tic Tac shaped object. So we have to take some estimates here. The thing was about 40 feet long. It's almost the length of an F-18, and F-18 is about 15,000 kilograms. So we lowballed this to estimating its mass to only be 1,000 kilograms. So it's basically an order of magnitude less massive than an F-18, while it's the same size as an F-18. So at 1,000 kilograms, the amount of energy that it had to deposit was on the order of 4 times 10 to the 11th joules. That's basically 100 tons of TNT, and would be the same as about 250 Tomahawk cruise missiles going off at once. And that's what should have happened when this thing stopped. And of course, none of that's observed. And which is shocking. So what's happening with the energy? Where does the energy go? You don't see heat signatures in the infrared, so we don't have any idea. This energy does not seem to be being dissipated in any way. Here's a clip from Hermann Oberth's presentation where he notes these high speeds. He says their speed is sometimes very high. 19 kilometers per second has been measured with wireless measuring instruments, radar. Accelerations are so high that no man could stand it. I don't think he realized how high they were. He says he would be pressed to the wall and bruised. You would be gel, actually, in the case of this Tic Tac here. The accuracy of such measurements has been doubted. And he says, if there would only be 3 or 4 measurements, I would not rely upon them and would wait for further measurements. But there is existing more than 50 such measurements. The wireless sets or radar of the American Air Force and Navy, which are used in all fighters, cannot be so inaccurate that the information obtained with them can be doubted completely. So he's making this argument that we continue to make, but he's made it over 50 years ago. Transmedium travel is another one of the 5 observables. UAPs can travel effortlessly in multiple media. Here we have, in this video, you can see the UAP is underwater. This is from the Aguadillo point case. This UAP, which is estimated to be rather small, a little bigger than a football, was cruising about 100 miles an hour just over the sea surface and then dipped below the water. And so here's a plot from the detailed analysis provided by SCU, the Scientific Coalition for UAP Studies. It enters water at just around 110 miles an hour, and its speed then drops to about 80 miles an hour, and then averages to the average speed while underwater is around 85 miles an hour. And it varies its speed slightly and then exits into the air. These transitions are not as dramatic as they would be if it was some of our equipment. So very strange that these objects can move from one medium to another, can keep their speed up. They don't seem to be impeded. They don't seem to interact with the water or the air. So this is very puzzling. And I put in here in red or pinkish, I guess, salmon colored. Can they travel in space in a vacuum? That's not been totally verified yet, but I suspect that's probably the case. And solids. Can these things travel in solids? There have been some observations of these things flying into mountainsides, and I would be interested in collecting more of that information, because if they can travel through solid, then if you can travel through water like this, very possible you could travel through solid. It's hard to imagine that the two are that different. And let's see, there was something else in my mind to mention with the water. What's interesting about traveling through water like this is that these things have been picked up on sonar. So there are cases when they've been picked up on sonar, but I don't know of any particular cases where they were traveling at a high speed and were observed to go into the water unimpeded and then were picked up on sonar. So we don't know if they're the same objects. This is one delicate point, is that since we don't know what we're dealing with yet, there could be various types of craft, each using different propulsion techniques and or different technologies. And to make matters even more confusing, you could have the same craft also using different technologies at different times. And so we have to be very careful not to speak in generalizations. Our first inclination is to try to generalize what we can learn from data, but these are not that easily generalizable. For instance, I could go pick a car off the road and it could be a diesel fuel car, or I can pick up an unleaded gasoline car, or I could pick up a hybrid, or an electric car. And the hybrid at times will be an electric car, but sometimes it'll be a gasoline powered car. So just like the Starship Enterprise can fly with warp drive or impulse power. So it's not clear that these things are all using the same technology. But what's interesting about the sonar recordings is that sonar requires that the sound waves bounce off the object. And in something like water, these are not displacement waves, they're pressure waves. So you've got basically the pressure wave has got to hit the object and bounce off of it. But if these things are able to move underwater at very high speeds, which has been observed, then, and it appears they're unimpeded by water, then you shouldn't be able to bounce pressure waves off of them. So it's not quite clear how sonar would work in cases when these things are moving through water at very high speeds. So there's another clue there as to what's going on, but it's not clear to me at this point what that is. All right, so low observability and cloaking. So here's an example again from the Aguadillo case. You can see it goes through various, it changes size, almost disappears at this point, and then comes back again, and it's blurry. And so often skeptics complain, oh, these images are always blurry. And it turns out there are possibly reasons for that. And it could have to do with the physics that are involved. Some of these objects appear to have plasma sheaths surrounding them. And here I'm using, here's the gimbal video, US Navy gimbal image from their video that was recorded in 2015. I have superimposed next to it a picture from a Super 8 film taken by Ray Stanford back in 1985. And this is, of course, Ray Stanford is debated throughout the UFO community. And part of the reason is that he does not want to share his imagery with UFOologists, and so he'll share with scientists though. So people don't all get to see this, and that seems to get people's undies in a bundle. And Ray is an interesting character who's made some pretty fantastical claims throughout time. So it's difficult to know what to believe. And so I want to make the point that this imagery is not independently vetted. We have not done that yet. I've been working with Ray over the internet for the last year or so, and I'm hoping to visit him this fall, where we'll get his films digitally scanned and authenticated. So we plan to do that. Now, others have seen these films or seen still images from these films shortly after they were recorded in 1985. And so despite the fact that this image is possibly contentious, I decided to include it. And I include it with that statement that this has not been independently vetted, but we plan to. And there are several reasons I included it. One is you can see what looks like could be a plasma sheath surrounding this. So this was a nice example of a plasma sheath. The object appears to be disc-shaped, surrounded by a plasma sheath. And I actually checked with some of the people at SCU to see if they had imagery that had been vetted that demonstrated plasma sheaths, and they did not have any. So one of the difficulties here is that most images of UFOs have not been independently vetted and authenticated. So it's very difficult to pull an image up and say, oh, this is this, and this illustrates this. This is one of the problems. And this is why we're collecting data now. This is why I'm working with UAP-X. So I'm showing this because you can see the plasma sheath. You can see that the object looks similar in shape to the gimbal image, which I find to be interesting. especially since this was recorded in Stanford's image is 1985, and this is 2015. And we've had some people claim that the 2015 image is just jet exhaust. Well, this jet exhaust looks very similar to images that Ray Stanford has captured. Another important point that this image makes, so this image I'm including because it makes several points, is that the object was traveling in this direction of the arrow. So the object is traveling to the right, and it's a disk that is traveling basically when these disks hover, they'll hover like this. When it's time for them to move, they tip up on N 90 degrees, and then they travel in the least aerodynamic way possible, which is really interesting. And you can see this here in this image, from the claim from Ray Stanford, which direction it was moving. So we have to take him at his word for that. But I'll back that up with other statements in a moment. And another thing you can just make out in this image, you can see a very light beam, what looks like maybe some kind of beam or line coming out of this object, coming out of the point here, which Ray calls the tower. He contends that this is a plasma beam that is fired off in the direction of motion. So, so that's interesting too. And of course, the gimbal video, this thing wasn't moving. Remember, it was just hovering, and they were circling it, and the thing would change its orientation at times. It would have been nice for them to record the video until it took off, or for us to be able to see that video, but I don't know if that even exists. Now, what is the importance about this plasma beam? Well, this plasma beam, what appears to be a beam in that image, is important because we now have a technique for achieving hypersonic velocities. And that is to basically fire a laser out in front of the craft. So you fire a laser in front of the craft and you heat up the air, and that basically creates a plasma explosion of air that creates a shock wave. And the shock wave usually would be on the nose of the aircraft. But if you shoot the plasma beam out, you can create the shock wave back here, and the aircraft just travels within that shock wave at hypersonic speed. So it greatly reduces drag. And this is a technique that we're actually using at this point. So this appears to be similar to what is being observed here. So since I'm interested in the physics and the engineering, this could be evidence of a type. It could be a plasma beam that could be used to make a shock wave so that this thing can travel through the air more freely. So to not show this image would be kind of foolish, because we might be missing some physics here, but we can take it with a grain of salt until it is authenticated. Now, this traveling in the least aerodynamic way possible is interesting, again, because Hermann Oberth noted in his 1954 talk that the disks typically fly bottom forward. He says the disks always fly in a manner as if the drive is acting perpendicular to the plane of the disk. When they are suspended over a certain terrain, they keep horizontal. And when they want to fly very quick, they tilt up and fly with the plane directed forward. So this has been observed multiple times. There are other cases of this where people have seen this happen, just as Ray Stanford had described. Now, I'm also told, I also have some evidence that the aeronautical engineer Luc Mirabeau had seen this and was inspired by this description. And it's also known that he worked to develop this this plasma beam ahead idea. So I'm right now researching what his connection to what the connection of Ray's imagery is to Luc Mirabeau to the development of this technique. It could very well be that this is one of the first techniques that was developed and inspired by UFOs. Another aspect of low observability and cloaking is what we call multi-imaging. UFOs are often observed to split into multiple objects. In many cases, this appears to be an optical effect, and it contributes to the blurred imagery. So these are individual frames from the Aguadillo, Puerto Rico case of the object moving, and you can see at this point the object appears to be splitting up. I think it goes like this, and it splits up here and then makes what look like two objects. And they actually separate for some distance until this one fades away, and then you're back to the original object. So there's some kind of optical distortion going on here. And it could be that, it could be something else, it could be more. So here's a picture of the multi-imaging. You can see it happening there. And the upper one is starting to fade. So some of this multi-imaging can be very subtle. Multiple images can appear many times a second, which we call flickering. What you want to do in these cases is image this with as fast of a frame rate as possible. If you're taking photographs, you want to take it very high speed, 1/2000th of a second, as fast as possible. And you'll get multiple simultaneous images of the object. And sometimes these images can be seen to have different orientations. So it may not be simple refractive effects. And sometimes it looks like these objects are dividing or spawning new objects. And it's not clear whether that's actually the case or whether it's optical. The distortion field. Objects are often surrounded by a volume through which the background imagery can appear to be distorted. Here, as this object, watch again, it'll recycle. As he flies over the lines, you'll see the lines warp around the object. I hope you can see that over Zoom. You can see the lines distorted. So is this a refraction effect? Is it due to a varying index of refraction around the object? Is this due to plasma or the heat from the object? One might think this. We have some reasons to think that's not the case. Or is this a distortion or lensing due to a gravitational field around the object? And these are all important questions. Now for some physical of our observables, which we're going to introduce that were not discussed by AATIP. One is low temperature. Some of these UAP, or many of them, turn out to be cold objects. They're not hot. You don't see any waste heat. You don't see any waste heat. In fact, you see the opposite. You see that they're cold, which is very strange. So here's an image from the US Navy's Go Fast video. Some people have claimed this is a seagull and that it's not going fast. I don't think any of that's, well, first, it's not a seagull. And I don't think it matters whether it's going fast or not. Go Fast is the name of the video because it looks like it's going fast in the video. I don't think its speed is the important point here. What I see as the important point is the object here in the center inside the reticle is white. And you can see that the camera is set so that hot things are black. You see the BLK down at the bottom. That means hot things are black, cold things are white, and this object is colder than the sea surface. So that's very unusual. You expect a machine to be able to be dissipating waste heat, but it's colder than its surroundings. Is it a balloon? No, a balloon would be in thermal equilibrium with the surroundings and would be the same color in this infrared image. Is it a seagull? No, a seagull is warm-blooded. It would be hot and would be black in this image. So it is neither a balloon nor a seagull, and it is strangely cold. And that's what I find to be the important point. The other thing about these videos is many skeptics have argued that, these videos aren't impressive or, they don't provide a lot of information. And I don't see that as the purpose of these videos. The importance of these videos really is that these videos corroborate the eyewitness testimony of the pilots. These videos are basically corroborating evidence. So to pick these apart and look for all these little crazy things is really pointless. These are corroborating evidence, and you don't expect to be getting a lot of data from these videos. So we at UAP-X have been collecting our own videos, and I'm going to show you one of those now. This is a FLIR video, a long wave infrared video taken with a thermocam it's a PM695 thermocam. That's a jet airplane. It's hot, hotter than 64 degrees below zero. And it's being followed by this object. This object was actually picked up on 2 cameras. You're actually seeing it on 2 cameras at this point. The jet airplane was only picked up on 1 camera. So this is not an artifact. This is an actual object. When you zoom in on this, it looks like it's trefoil shaped. I jokingly like to call it the Klingon bird of prey, but because it looks somewhat like that. That's a jet airplane. That's a passenger jet. It's coming into land. It's about 3,000 feet. Assuming that this object is at the same altitude, it's about the same size as the passenger jet, although we don't know what altitude it's at. What we do know from the temperature is it's much colder than, its temperature is down around 60 degrees below zero. So this is a very cold object. Also, strangely, many of our recordings we detect these things on the long wave infrared cameras, which are very useful because we can get temperatures, assuming that they're black body radiators, but they're not visible with shortwave IR using night vision cameras, and they're not visible in the visible range with the naked eye or binoculars. So this is also another example of low observability. Some of these things are not observable in the visible wavelengths, and we actually have some testimony to that from the pilots in the USS Roosevelt case, where they were picking these things up on radar and not seeing them until they were right on top of them. So this low observability is, again, an issue. It's not clear whether, just taking telescopes and aiming telescopes at the sky as the Galileo project wants to do is going to work, especially because we've had experiences where we've only seen these in long wave infrared. Now, there's a hypothesis that these things are using general relativity in some way to create these warp bubbles or use anti-gravity in some way. Now, with anti-gravity, if you're hovering, you basically want to have anti-gravity on the bottom where you would expect a blue shift, and you'd have gravity on the top where you'd have a red shifting. Or if you're moving, you're going to be red shifted in front and blue shifted in the back, and to propel yourself. So this is the gravitational redshift, and a hovering craft ought to be strongly blue shifted on the underside, which should appear hotter, not colder. So the fact that we see a strong, the fact that we observe these objects to be very cold seems to run against the hypothesis that these things were warping space-time in some way. However, the strong blue shift of a thermal black body radiation that is hypothesized here could explain radiation burns in victims. So during these encounters, and there's numerous cases of this. So again, it's difficult to generalize. The craft that we are looking at with our infrared cameras that appear to be cold might not be warping space-time, but other craft might be warping space-time. So we can't just make generalizations here. But we got to keep all of these hypotheses on the table. So are these things warp drives? There's a good question. Well, an interesting thing that we noted, I was working with Matthew Shadagas, and we both noticed this, is that one type of warp drive spacetime that's been recently published by Bobrick and Martyr has a physical shape that looks very similar to what you see on in the gimbal video and Ray Stanford's video. So is this a coincidence or is it not? So it's not clear whether this is evidence that this is a space-time warping or not, but it's a possibility that we need to consider. And of course, we know that these craft create strong magnetic fields, strong electromagnetic fields. These fields can adversely affect electronics in airplanes and other vehicles. And there is some additional evidence for this, which I don't have in this talk. And that is pretty much it, what I have for their characteristics in physics. Some of these UAP appear to be anomalous physical objects, and they exhibit numerous observable physical effects. Of course, we can't assume that they're all the same type of craft or the same type of thing. We can't assume that they have the same origin, characteristics, or even the same technologies. And even a single craft might have different technologies during different modes of operation. So it's very difficult to put all of this data together and to come to some concrete conclusions. Potentially, we're looking at a diversity of technologies that may exist to match the diversity of objects. And I'm working with UAP-X to actively study these things.